All right, we're going to be moving on from math, and we're going to be doing some probability and statistics. Let's roll. Okay, so for our first one, we got two people are attempting a three-pointer. One has a probability of 1/2 to make it, and the other has a probability of 1/5. What is the probability that at least one will make it? So let's first list our probabilities of each. We're gonna give the person with the half chance, we'll just denote it as A, so probability of A happening, 1/2. We'll give the other one B, so probability of B, 1/5. So this question is a classic law of total probability. So if you go to page 64 of your FE reference handbook, you're gonna find that equation. So let me write that down. All right, so there's our equation. So this equation is good when you have two probabilities and you just wanna, there's a fly in here, and you just wanna find the probability that at least one will happen. So that's our question, we're gonna go for it. Okay, get out of here. Anyway, this fucking, what do you, is it dead? No. All right, moving on. So probability of A, 1/2, plus probability of B, 1/5, minus probability that both happen, I'm jumping the gun there, will be 1/2 times 1/5. So as we know, to add fractions, we're going to find a common denominator, which is going to be 10. So 5/10 plus 2/10. 1/2 times 1/5 going to be 1/10. So we'll find 7/10 minus 1/10. 6/10 equals 60% chance that at least one will make it. All right, so for our next problem, we got test scores from a class are normally distributed with a mean of 82% and a standard deviation of 3.2%. What is the probability that a test score will be above 90% or below 75%? So at the first sentence, we saw that it's normally distributed. Distributed. The fuck? Anyway, so if we go to page 67 of the reference handbook, we see that there's our normal distribution, or information about the normal distribution. So on there, you can also see how to find the z values. Okay, so for the z values, let me just write the equation. X minus mu over sigma, which is x, the point that we're interested in, minus the mean over the standard deviation. So first we're gonna do z of that 90 value, so 90%, but 90 minus 82 over 3.2, it's gonna give us 2.5. So then the z of 75 is 75 minus 82 over 3.2, which is gonna give us negative 2.19. But as we'll see later, we can't use 2.19, so we're going to be using negative 2.2. So next step, we're going to go into the reference handbook again, and on page 76, you can see the normal distribution values that we need. So you can see on this page the normal distribution values that we're going to need from the z values that we just used, or we just found. So on that page, we're going to go to where it says r of x, and we're going to find those values corresponding to the z values, which on that page is denoted as x. But same thing. So if we go down the left column, we go down to 2.5, r of 2.5. Let's write that. R of 2.5 equals 0.0062. And then you can see there's no negative there, so we're just going to use 2.2 because it's a normal distribution. It's the same on both sides. So R 2.2 is equals 0.0139. So now to find the probability that a test score, a random test score taken from this sample, is going to be either above 90% or below 75%, we just got to add those two numbers together. So the probability that X test score is less than 75%, or X is greater than 90%, going to be 0.0062 plus 0.0139, which is going to give us 0.0201, or about 2%. Low chance. Alright, those are the first two of probability and statistics. I hope those helped. Pretty easy, pretty short. I know I was kind of fucking around this one. But you know what? I'm taking these videos too seriously. Let's have some fun. Alright, see you in the next one.